Today we're going to be looking at negative and fractional indices. So let's start with an example. Let's say we have x to the power of 3 over x to the power of negative 3. Now when we have an arrangement like this, this is the same as saying x to the power of 3 divided by x to the power of negative 3. And whenever we're dividing two numbers with the same base, x, we simply have to minus the two powers from each other. So this is the same as saying x to the power of 3, and then we got minus, obviously the division means we've got to take it away from the negative 3. And we know that 3 minus 3 is the same as saying 3 plus 3, which is equal to 6. So the result for x to the power of 3 minus negative 3 must equal x to the power of 6. Now let's look at another example. Okay, so what if we have x to the power of half, and we're going to multiply that by x to the power of 3 over 2. Okay, so we now have our base, and we've got two fractional indices. And whenever we have a multiplication, all we need to do is add together the indices. So this would mean we need to add half and then add 3 over 2. Okay, and we can see that the denominators are the same. So we can simply add together the numerators, 3 plus 1 equals 4, and we keep the denominator the same, which is 4 over 2. And 4 divided by 2 is simply 2. So what we need to do up here is we're going to rewrite this expression as x to the power of half plus 3 over 2. And so that must therefore equal x to the power of 2. Let's try something slightly different. So what happens if we have x raised to the third power and then all of that is raised to the 2 over 3 power? Now when we have something raised to a certain power and all of that raised to another power, we have to multiply the two powers. So we have to have x would be to the power of 3 times 2 over 3. Okay? And 3 times 2 over 3 is simply 3 over 1 times 2 over 3. And we can simply multiply the numerator and the denominator. So 3 times 2 is 6, and 3 times 1 is 3. And so 6 divided by 3 is equal to 2. And so we know that 3 times 2/3 is equal to 2. So that must mean then this expression here, where x 3 times 2/3 must equal x squared. Okay, let's try something else. Let's say we have the cube root of 125 x to the power of 6. What would we do here? Now, the first thing that we should think about is what is meant by the cube root. We want to try and change this into a form which we are more familiar with. Now, if we have x, the cube root of x, that is the same as saying x to the power of 1/3. So we know that both 125 and x to the power of 6 must both be to the power of 1/3. So let's rewrite this expression again with that knowledge in mind. So we have 125 to the power of 1/3, and that's going to be multiplied by x to the power of 6 which is also to the power of 1/3. And at this point, we can work out what the cube root of 125 is, and the cube would be x times x times x must equal 125. And so we need to work out what is x, and we can work out that x would equal 5. So the cube root of 125 is equal to 5. Okay, so if we just rewrite that expression again, we've then got 5x to the power of 6 raised to the third power. And as we saw just a moment ago, we know that when we have something raised to a certain power, which is all raised to another power, we need to multiply the powers together. So this is 6 times 1/3. And if you've got a standalone integer like 6, I always like to put the actual denominator underneath as 1 just to make it super clear what we need to be doing. So it's going to be 6 times 1 equals 6, 1 times 3 equals 3, 6 divided by 3 equals 2. So x to the power of 6 to the power of 1/3 is the same as saying x to the power of 6 times 1/3, which must equal x squared. So we can therefore rewrite this expression as 5x squared, giving us our answer. Now let's evaluate a negative fractional indice. So let's say we have 25 raised to the negative 3/2 power. Now we should know that whenever we have a number raised to a negative number, like such, that is the same as saying 1 over the base times the positive of that power. So a to the negative x is the same as 1 over a to the x. So we could therefore rewrite our expression here, 25 to the power of minus 3/2, as equal to 1 over the same base to the power of the positive indice, 25 to the power of 3/2. And whenever we have an expression like this, this is the same as saying 1 over 25 to the power of a half times by 3, as we've seen before. So we split this into two separate powers. We know that half times by 3 is the same as 3/2. And we should also know that 25 to the power of a half is the same as saying, if I just write this out for you, 25 to the power of a half is the same as saying the square root of 25. In the same way that 25 to the power of 1/3 would be the same as saying the cube root of 25. And we know that the square root of 25 is equal to 5. So we can rewrite our expression above as saying 1 over 25 to the power of half, which is equal to 5, and then all of that to the third power, 1 over 5 cubed. And 5 cubed is just 5 times 5 times 5, which is equal to 125. So let's look at a slightly more difficult example to finish this off. So given that y equals 1/16 x squared, express the following in the form kx to the power of n. And the example is y to the power of a half. So our first step is to substitute y equals 1/16 x squared into y to the power of a half. So let's do that. So this is the same as saying 1 over 16 x squared, which is equal to y, and all of that is raised to the power of 1 over 2, to the power of a half. And we know that whenever something inside a bracket is raised to a certain power, every element within the bracket must be raised to that power. So we can rewrite this as 1/16 to the power of a half multiplied by x squared to the power of a half. So it's always a good idea to try and break down the complicated expressions that we have into something that we can manage and understand. So let's deal with the first aspect first. So 1/16 to the power of a half. When we have an expression like this, and we have a fraction raised to a certain power, both the numerator and the denominator must be raised to that power. So we can rewrite that again as 1 to the power of half over 16 to the power of a half. And as we saw earlier, we know that when a number is raised to the power of a half, that is the same as saying the square root. So it would be the square root of 1 over the square root of 16. And when we have the square root of 1, that's just the same as 1. So the square root of 1 is 1, and the square root of 16 is 4. Okay, so let's now plug that into the equation that we have down here. So we now have 1/4 multiplied by x squared to the power of a half. So now let's deal with the second aspect here. And we saw earlier that when we have a number raised to a certain power with inside a bracket, which is then raised to another power, we have to multiply these together. So we know that x squared would have to be multiplied by a half. And that is the same as 2 over 1 times 1 over 2. We multiply the numerators and the denominators, so that would be 2 over 2, and therefore that is equal to x to the power of 1, and x to the power of 1 is just x. So we can now plug that into our expression down here, and we've now got 1/4 times x, and if we multiply those together, that's just the same as 1 times x is x. You know, we could almost write it out like that. So 1 times x is x, and 4 times 1 is 4. And that gives us our final answer. If you have any questions about this video, please leave your comments below and I'll get straight back to you. Thank you very much for watching.